Alright guys, so today I kind of want to show you guys how I set up my PCBs for doing like hot plate or reflow oven, just kind of generally how I organize stuff, all of the recommended items that I would say you need to kind of get a pretty successful assembly build. So the first thing I would do if I'm going to start doing a PCB assembly is I would get all of the components organized in trays if possible, and then clearly marked on the reference designators. I would get a printed out schematic. You could use your computer if you want. Obviously, you need your PCB, which we know we got, and then I use these for fixturing. So this, along with some blue masking tape, um, this is for cleaning the PCBs after you reflow. This is a vacuum pen. You don't need a vacuum pen. You can actually use a pair of tweezers. Obviously, you need some solder paste to reflow, and I'll show you how to squeegee these on a little later. You'll need a credit card or some way to spread the solder paste. Isopropanol alcohol that's used with these brushes for cleaning. You'll need a stencil. This is from Osh Stencil, so these should be coming in on Monday, I believe. This will be needed to squeegee on the solder paste. You're also going to need some chem wipes to clean off the stencil because we need to reuse this stencil. And then extras to kind of make it easy after we get the board assembled. If you have a microscope, either using like a standard microscope like here or something like on a monitor would be nice to check your work and make sure that you have clean solder joints. Okay, so once you have everything you need, this is when I think like the most critical step to have a really good transfer of solder on your PCB. You need to set up your fixturing right. So what I have got here is just some 3D printed spacers, but you could use any scrap like PCBs. I just have these lying around, so I could use these. And you want to set it up so that you tape it down to your work area, and then you get a surface that you can squeegee on without the board moving, because a lot of these fine pitch parts, so we're going to be doing the buck boost converter, which is like a relatively fine pitch part, along with the accelerometer. You want to have as good of a transfer of that solder paste on the solder mask as possible. So I'm going to finish masking this all up, and then I'll show you how to transfer it over. So doesn't have to be perfect. You just kind of want this to be solidly masked down with your spacers and your PCB, and then get some blue masking tape on the stencil as well, just on the top and bottom. Works good from what I've seen in the past. And you want to make this aligned as best you can. Essentially, you just want the solder pads. You just want the solder mask openings. So it might just take your time. This is a very critical part to make sure you have good alignment. If you have bad alignment, the solder paste won't really go on those fine pitch parts. Okay, so this is a pretty good alignment. Then you just kind of use one hand to hold it fixed, and there you go. Okay, now don't put too much solder paste on here. You kind of just want definitely enough to fill in the gaps, but a little bit goes a long way, and all of the residual paste is going to essentially be discarded after this. All right, let me see if I can get some out. All right, that should be good. All right, and then you're gonna make sure everything is clean too. So I also use isopropanol alcohol to kind of make sure there's no like lint or debris on the solder spreader, which is just a plastic credit card or whatever you have on hand that will work. And what I try to do is I try to get a 45-degree angle, and then when I press and spread the solder, I'm just kind of trying to smear it on, and I might not get it perfect on the first pass. So here I can kind of see that I actually, just on that one swipe, got solder pretty much everywhere I need. So now I'm just kind of cleaning off the residual, so it's not an excessive amount of solder. And then here I might actually put a little bit more, so you can kind of do a second pass. It's not super critical that you do it in one shot, but you definitely want enough solder on these fine pitch parts. So you can kind of go over it a couple times here. I'm just kind of showing you it's a little bit more forgiving when you have everything fixtured down. Yeah. Okay, now this is also another important part. Just try to lift one side at a time. So I'm just gonna lift the whole mask up to take it off, and there you go. So this doesn't matter. This could be set off to the side. You're gonna clean that. And now I'm just kind of looking, doing like a visual inspection. Now, if you had a microscope and you kind of looked under the microscope, you can kind of verify that like all of the solder paste transferred cleanly. It doesn't have to be perfect, but you definitely want enough solder. It's going to reflow and spread out and kind of go to all the metal once you get it at soldering temp. So this looks good just with my naked eye here. And then I'm going to go ahead now and start with the assembly. So actually, you want to probably keep it in this fixture for when you place all the components on there, just to make it easy for you. It's nice to have a fixed working area. And then I'm just going to kind of go and place all these parts. And then also, before I kind of do that, I would recommend that you clean the stencil. So to clean the stencil, I just use the isopropanol alcohol and kind of not directly with the brush, but I just kind of wipe this down, and this is basically just cleaning off all that residual solder paste. This is very important because you want to set this up for the next person using the stencil, and if you don't clean it right away, it will dry out and kind of ruin these stencils. These are a little bit more delicate than the stainless steel, so you want to kind of make sure you do things, you clean up after your mess. This is important. Okay, so before I just kind of place all these components, I do want to just point out that you could do all of these with the tweezers, but the vacuum pen is going to be a little easier, especially for kind of the more finer pitch parts. I will bring this into the lab hopefully on Monday, and when you guys plan on building up the boards with the stencils and trying to get this all done, so I can bring this with me. But again, I'll kind of pause on the video and just show you how to get these parts placed and my technique for kind of holding things down. But for all the passives and all the other components, I'm just going to place them right now. Okay, so once you get to the spot where you need to place the LIS 3DH or the buck boost, you can do them with tweezers, same method. I'm going to use a vacuum pen just because I have a little bit more tight control of it, but I'll kind of show you. So what you want is you definitely want both of your palms on the work surface when you're starting to place and ready to drop. So this could be with the tweezers or with the vacuum pen, but once you pick it up, so with the vacuum pen it's pretty simple. I'm picking up this device. This is for the buck boost converter. I'm gonna kind of align it as best I can, and both my palms are down, and then just get it to barely touch the solder paste and let go. And take your time here. So what you can do is when you just place it, if you place it with your tweezers or a vacuum pen, you can make really micro adjustments to get it to move very gently. You don't want to press down, you just kind of want to press on the sides. And then here I can see that it's within the kind of outline, the silkscreen outline that we set. So I'm not really going to touch it anymore, and you don't have to press it down. Once you reflow, all of the solder will kind of automatically align the part. So it can be a little bit offset, but you want to try to get it as perfect as possible on the first shot. Okay, so for the LIS 3DH, same thing. Make sure you got your pin 1 dot aligned. So this is for me on the upper left corner on the part. And then I'm going to do the same thing. I'm kind of going to align it with the silk screen as best I can, and then drop it. That was a pretty good drop. And then I can make a very subtle movement with the tweezers. And there you go. So one more part I got to place. This is actually just for a custom PCB I'm doing with a different microcontroller, but the those are like the hard parts to place. And then the next step is we're going to do a reflow, so we can either do a hot plate or if there's a reflow oven available. I believe there's one in the engineering lab on campus, but there's I might also be able to bring in my reflow oven, and I'll show you that step next. Okay, so like I said, reflow oven, this would be ideal if it's available, but this can also be done on a hot plate, especially because we're only going to be doing one side of the board. As soon as you want to populate components on two sides of the board for maybe your like final design, that's when you need to use a reflow oven. And then the trick is that you're using two different types of solder paste. These typically come in the solder paste packages. So we are going to be using 6337 lead to tin. And then you can kind of see here that we're only really at this high soldering temperature for maybe 10 seconds in this hot zone here. A lot of this is just like pre-bake and a pre-soak. I've already set this up on a custom profile here, but when you do a hot plate, you're basically going to have to babysit this and watch for when all the components and all the solder paste liquefies. I'll try to capture this as best I can in the reflow oven to kind of show you if I can get a light on it, and then we'll go from there. Okay, so we're kind of in the middle of this profile now. We're in this reflow phase up here on this ramp. You can kind of see this plot is pretty much tracking, and this is for the leaded solder paste, trying to get up to 235C. So eventually this is going to peak out, and then this door will open, and then I'll show on a video kind of like that pivotal moment when the solder liquefies, and then you can kind of see the components make their own micro adjustments to make the alignments with the pad. So I can even see it right now. That solder is just starting to reflow, and you can kind of see that liquidification. And I'll show you closer up in the video. Okay, so the reflow is done. Now it's just cooling down. If you're on a hot plate or if it's cooling down in the oven, just be really careful. It takes a little bit of time. There's a good amount of copper in there. It takes time to cool down. So when you do take it out, make sure you use tweezers, be safe, wear gloves, at least if you have them, and go from there. Okay, so here's an example where one of the larger components had like a little misalignment with the pad. So I'm actually using the hot plate along with some flux that I put on the solder joint. So I'm going to put a little bit more flux just to kind of highlight that on the solder joints. And then I'm trying to actually just make a micro shift of the part while it's on the hot plate, while the solder is liquefied. So I'm just kind of using these pliers to put some tension here, and then see how I made that little subtle motion. You do not want the board on the plate for that long, so you're gonna go ahead and take it off, turn off the hot plate, and then let this cool down. So you can always let it cool down on top of like some other PCBs if you take it off, but just be really careful. Like this is really hot. And that did the trick, so I was able to kind of get that alignment. And then the next step, once it cools down, we're going to clean it with the isopropanol alcohol and some brushes. I also put a toothbrush, so a toothbrush works well, but you do not want it to be super hot. But if it's warm, it's easier to get the flux residue off, and it's just best practice. Okay, so just take a little bit of the isopropanol alcohol, go ahead and brush it. These components will not come off. You'd have to brush it pretty hard, probably with a wire brush, but these are plastic bristles. And then what you're trying to do is get all there's solder balls, there's flux residue. You want to get that all off. Use the chem wipes. I kind of use this. This kind of helps pick up some of the residue and helps get the board really clean. You want the board as clean as possible before you kind of look at it. It's easier to see the solder joints. And then the next step, we'll look under the microscope. Okay, so if possible, microscope is your friend. This is the LIS 3DH under the microscope. A couple things just to kind of note here, right? So I didn't clean this board perfectly. You can see, I'm going to try to show with the tweezers, that there are solder balls kind of like by this capacitor, and it's kind of dirty, right? But overall, the reflow on the device was pretty well. There's one pin that doesn't have a lot of solder. That's down here on the bottom left corner. I'm going to try to poke it right there so you can kind of see with the tweezer. So I've already checked continuity here and like made sure that there was solder, but this is a pretty good looking device. Sometimes you will have some of the pins solder to each other, and so you'll need to fix that before you want to test. But in general, that's kind of like the general steps. Yeah. Okay, so another view. This is the buck boost converter. Actually, most of these pins look pretty good. Maybe just the center pin here. This is actually a ground pin, right in the middle, right here with these, right next to this inductor. But in general, this is a pretty well soldered device. This should work. So the next thing I would recommend after you kind of get this initial build is I would do continuity checks first before you apply any power to the board. But in general, this is kind of like best practices, and good luck with your builds.